Hello everyone, and welcome to another mini Sky Tonight. So one of the topics I wanted to try to cover over is galaxies, what they are, how they're formed, and to talk about different types of galaxies and how you can be able to observe them. So let's dive into it. So what are galaxies? They're basically island universes, as I like to sometimes call them, or basically island cities. They're islands of stars, gas, dust, and dark matter. To which, believe it or not, I discussed about dark matter last time. So if you want to check out that video about dark matter and dark energy and the difference between them, I'll leave a link up here and you can check out what this type of infamous unknown matter is. But nonetheless, back to galaxies. Not only do they contain stars, gas, dust, and dark matter, they're very distant objects. They're several of millions of light years away from us. And there's thousands upon thousands of them that exist within our universe. So given all that we have seen of our universe, even with that small little 5% of our universe of material, we still are able to create thousands upon thousands upon thousands of galaxies. So how are galaxies formed? So we have to kind of do a little bit of a history trek back to the beginning of the universe, the Big Bang. So after the Big Bang exploded, all the matter of our universe came from it, including dark matter and dark energy, and the baryonic matter that we see today. So all these initial protons were being spewed out into the universe. And as that material cooled over time, it would start to clump together to create these super large stars. So kind of like how star formation goes within our own galaxy of dust and material clumping together to create stars, that's what happened with the original universe. Our universe was just initially filled with stars, not galaxies. But then those stars, since they were so big, they lived very short lifetimes. And they basically went through their stellar death to create the first black holes. And then those black holes started to merge together. And as they merged together, material started to go in orbit around these black holes, creating the first proto-galaxies. And as some of these galaxies started to merge together and started to merge more black holes and gain more material from the new cooling universe, some of the first galaxies were formed. And as it continued to spread out, more black holes started to get more and more galaxies and creating the universe that we see today. So talking about the history of galaxies, so that's how they are formed, but our understanding of galaxies wasn't recent. It wasn't until the 1920s that we actually understood galaxies to be galaxies. So up until the 1920s, from the early 1700s to the 1920s, we believed that the Milky Way was the only galaxy, and that we were just one star among thousands of stars, and everything in the universe orbited around us, and we were just all in our basically private little island. And it wasn't until the Greek Renaissance that we went from the Earth being in the center to the sun being in the center, but even then we still believe that the sun was the center of the universe. Sometimes it takes a little bit of convincing to basically tell people you're not the center anymore. We get it. So in this particular case, it took a long while. And you have to understand why they believed this way. Telescopes during that time had limited resolution because we were still trying to understand how to develop telescopes. Now, Galileo didn't invent the first telescope. He was the one that basically pointed up at the stars, and he was noticing different things and was able to propose unique things about our universe. But even then, telescopes were very limited about how big they were. Because I mean, Galileo's was relatively tiny compared to some of the modern day telescopes that we have today. So as telescopes got bigger and bigger and much more complicated and more sophisticated, we were able to see different things. In fact, it was up into the 1920s that we discovered what these really weird objects in the sky that had spiral arms on them, but we thought they were originally a part of our galaxy. So hence why we call them spiral nebulae. In fact, the image over here to the right is an initial sketch of our own galaxy done by William Herschel, where the black star in the center is our own sun, and the rest of the stars that he saw in the sky, he predicted, given their distances from the sun, where the sun was in the center, of what our galaxy looked like. Initial attempt. I mean, he had a good concept, but it wasn't quite right. And anything that was a unique object all existed around in our galaxy. We were the only island universe. It wasn't until the 1920s when an astronomer named Shapley and another one, Curtis, debated because they were noticing that these spiral nebulae seemed a lot further than many of the other objects in our local neighborhood for our stars. Like, these objects seemed much farther away and had unique properties that shouldn't be a part of our galaxy. So Shapley and Curtis had a huge scientific debate about whether or not these were own island universes in themselves, or they were just part of our own galaxy. Ultimately, the debate wasn't really decided until it was in the late 1920s when Edwin Hubble came into the picture. And he was able to find out the distances to these vast galaxies. It was Henrietta Leavitt and Edwin Hubble that basically laid the groundwork to basically say, these are indeed own island universes. They exist far outside our galaxy. So Henrietta Leavitt was able to figure out a means of figuring out the distances to these stars in these very distant nebula. And with her method, Edwin Hubble took her method and was able to use this method on very distant galaxies because he was able to access a very powerful telescope at that time, which is Lowell Observatory in California. And from there, he was able to measure the distances to these spiral nebula and found out they were millions of light years away. Like, the closest one to us, the Andromeda Galaxy, is 2.5 million light years away. Whereas in some of the furthest stars, we're just a few 100,000 light years. So for something that is millions of light years away is much farther than even the outermost stars in our own galaxy. So that, to Hubble, basically was the trigger that said, no, these are their own island cities in our universe. And so that's where our understanding of galaxies started. So what you may think, like, wow, it took them that long? Well, keep in mind, science is a slow progressing state to where we take what instruments and knowledge that we know of at the time and expand upon it slowly over time with new technology, new development, new ideas. Sometimes some of those new ideas are kind of kiboshed, but with further research and further study, some of those ideas come to fruition. So let's look at the anatomy of a galaxy. What makes a galaxy versus some of the other things that we see in our sky, like planets, nebulae, and things like that? What differentiates a galaxy from a nebula? Well, galaxies contain nebula. You basically have this central bulge in the center versus most nebula, kind of like what you see behind me, is very spread out. There's not really a central bulge in this nebula. It's kind of like thinned out over stretches, whereas in this galaxy, most galaxies have a bulge in the center of them. And for spiral arms, they have these beautiful spirals for different other types of galaxies, they have stars that go in orbit around them. Most spiral galaxies and or traditional galaxies contain this very thin line. So some galaxies we can see edge on, and we notice that there's globular clusters, or basically little clusters of, as I sometimes like to call them, mini galaxies that orbit around the bigger galaxy. So there are different types of galaxies. As I hinted, there's spiral galaxies, but we also have what are known as elliptical galaxies. Elliptical galaxies are basically big, huge elliptical blobs or spheroid blobs. But then you also have what are known as spirals, kind of like what we're in our own galaxy, or barred spiral. And we'll kind of show you some examples of the different types. And irregular. They just don't fit either into elliptical or spiral because they have just a weird, odd shape. So we call them irregular galaxies. So this first one is an elliptical galaxy. It literally looks like this big, huge elliptical orb of some kind. So we see stars and we've detected them, as you can kind of see some of those faint little stars around there. And we notice some globular clusters that orbit around them. Astronomers believe that the elliptical galaxies were the combination of where two galaxies merged together, and they haven't settled down yet. Basically, they're an elliptical blob. This is a beautiful spiral galaxy. So you can see like the central bulge in the center there, and you can see the beautiful pinwheel style arms that go around the center bulge. Now, the false colored images that you kind of see in this basically show star forming regions, whereas in elliptical galaxies don't have new stars being formed. Whereas in spiral galaxies, since they've kind of settled down a little bit and created that beautiful thin disk, they can start the process with nebula creating new stars. And of course, barred spiral galaxies. So as you can kind of see it kind of, to me, a barred spiral kind of looks like a baton with ribbons at the end, kind of like what you see with like baton twirlers with in gymnastics and or in a band of some kind, like a marching band, like they have the beautiful baton with twirls on the end. And so basically have this bar in the center there, and the arms kind of extend from the bar. Versus a standard spiral galaxy, which is basically a circular orb in the center, whereas in this bar extends outward and creates the arms. And then you have irregulars. You don't know what to do with them. Most of irregular galaxies are the result of what is called galactic cannibalism and or galactic merges. So in this particular case, the galaxy in the upper part right is basically eating the galaxy in the bottom left and creating like this chaotic structure that you're seeing. And as you can see in the false color images, because these stars are being, or these galaxies are being intertwined, all the material in the nebula are being excited in both of these galaxies as they're being combined, that new stars are being formed in them. It just looks really odd and weird. So, believe it or not, Hubble started to know the differences in these different states of galaxies. And as he looked at different galaxies, he realized that maybe these different types of galaxies indicate the formation of a galaxy over time. That it's kind of like looking at a person over the course of their life, but it takes so long to see galaxy evolution, kind of like it takes so long to see a person go from a boy to a older gentleman. So sometimes you look at different people in their different stages in life and infer that, oh, given this certain stage in life, given this certain stage in life, given this certain stage in life, you can infer a natural timeline within a few minutes by just looking at a different mixture of people and saying, oh, most people start off as a young kid, and then as they get older and older and older, they gradually become an older gentleman. That's what Hubble did with all these different galaxies he was observing. He started to infer, after looking at thousands of galaxies, that there was a natural trend, that many of the elliptical galaxies then start to come into basically initial spiral galaxies, and then they start to turn into either standard spiral galaxies, unbarred or barred, and or they're intermediate, and then you just have the weird odd irregulars. But many of those irregulars, he suspected, that would then turn into ellipticals over the course of their life. So he suspected that when galaxies merge, they were in a chaotic and irregular state, but as they start to settle down, they turn into elliptical galaxies. And over time, given the dynamics of the black holes that were merged, they can either become spiral galaxies or barred spiral galaxies over the course of their lifetime. And this is what was known as the Hubble tuning fork, where basically you could have the spirals and the unspirals and stuff that's intermittent in between, creating a tuning fork of some kind. So to kind of talk about our galaxy, what is our galaxy? Our galaxy is a barred spiral galaxy. Many people grew up, I know I grew up believing that our galaxy was a spiral, but it was in the late 1990s that we discovered unique structures in our own galaxy thanks to the Hubble Space Telescope and different types of other spacecraft, that we noticed certain weird structures in our own galaxy that indicated we were a bar and that we were somewhere right here looking down the bar. We were a small barred spiral galaxy, but a barred spiral nonetheless. So this is basically a synopsis of galaxies, how they're formed, what they are, and a little bit about it. So to observe galaxies in the nighttime sky, I would recommend getting a star map. And most galaxies on a star map are indicated by little ovals, and some of them are incredibly faint. Keep in mind, these are several millions of light years away, so you have to go very far away in order to be able to get a good view of these galaxies. So get away from city lights as much as possible. And since these objects are so far away, they're incredibly faint. So get out from the city, go out into the country, and get a good star map and look for them. They'll look like little fuzzes in the sky. And as you look at these little fuzzes in the sky, you can start to understand and appreciate why many of the older astronomers called them spiral nebula, because they thought, oh, they're just like the nebula that we see in our galaxy, because they look like little fuzzes. So this is about galaxies. So if there's a question or any confusion about galaxies that you would like for me to cover over, leave it down in the comments. If there's a topic you would love for me to cover over, leave it down in the comments as well. And until next time, stay safe, stay healthy, and as always, never stop learning.